Hi, this is Vasily and you are watching UV transformation tutorial. Let me show you a few references. Go back to cinema. This time I will start from the plane, and actually I need to display wireframe. I'll create a Redshift material, apply this to the plane, open it, and here I need a state node. Actually I will show what is UV coordinates. So I need a CFD shader, which will be a gradient. First one would be in a U direction, which means horizontal, but it's better to have this as a red color. Go up, wrap this into a fusion node, duplicate gradient, change it to a green color, and change type to vertical direction. Now go back to fusion, change mode to add. I need now a texture node, because we can directly connect CFD shaders and textures. Okay, this would be a viewport, and this would be a surface. It's a UV map, which comes from a full black to a full yellow, where red color means the direction U of UV map, and green color means direction V of UV map. And if you'll apply, for example, random, I will change this to point, reduce the strength. You may see that this UV map is actually stick to its surface, and even if you will move this object in 3D space, UV map is always stick to its surface. And while we are actually working in 3D space, I'm going to show you how to affect from 3D space to 2D map. Let me open the material again. Here in the state node we have tangent and bitangent states, and actually tangent will convert UV map into 3D space by U direction, and bitangent will convert UV map in V direction into 3D space. So I can just connect this tangent into the material, into a diffuse color, for example, connect to surface, open a render view, and you see this bitangent currently colors everything in red color. That's because our U direction comes into positive X position. And if we will rotate our object 90 degrees along red Z positive axis, everything colors as blue, because now U direction of the object orients along this positive Z axis. And the same actually for bitangent. Currently you see V direction orients along negative X, and we see full black color, which is actually not a black, it's a negative red color. So if you rotate this like this one, here we have a V direction of UV map comes along positive X direction, and which is why it's colored red. And if you will reset position, now it orients along positive Z direction, and it colors as a blue. Again, we can rotate this way, and now our V direction of UV map orients in 3D space along positive Y direction. Now I will create a node, drop plane under a node, and apply this material onto node. I will disable plane, create a cube, drop it here. You see actually we have a lot of UV maps around these cubes, but everything I told about the plane applies here as well. So currently we see the bitangent, and it's a green axis, and this face orients positive y direction, this along positive y direction, and this face along positive z direction. That's why it's blue. Now let me create a torus. Single field, draw torus here. This is very colorful node, but you see what we have. We have a green, which comes from black around this torus, go to the inner place, and comes here from inner to outside, and same is reflected here. Initially it comes into positive y direction, when it comes into the negative x direction, after that it comes to the negative y direction, you still see it black as negative x, negative y, and while it starts to turn into the positive x direction, it becomes red, comes here with red, and here it comes as a yellowish color because it's red plus green, and ends here with a green color. Okay, that's just a short theory. I'm going to make editable this plane, but before it I will increase signals count. Now I make this editable. I'm going to point mode. Now press Shift C and set its weight. Let it be 0. I will put it here. Use fields. Edit freeze. And I'm going to create a linear field. Go back to object mode. Okay, this linear field, it comes from red to yellow, and I'm going to affect my UV map from yellow to red. Means when it's yellow, our UV map should be affected fully, and when it's red, it shouldn't be affected. Now I will adjust that setup a bit. I will convert linear field to a group. Put it here, go outside, enable direction, and I will name this group field as a driver. I will create another group field. Let it be direction. And here on the direction field I create a solid. It has to be checked on the radio. Let me see. Read direction from here and drop this driver into that direction. And disable everything except direction. Now here in that weight map I will type a different name like weight. Actually I need to remove direction from here. Let it be normal. I will duplicate this and I will name this as an X, and I'm going to replace this with a direction. Now I'm going to delete this group field, uncheck the clumping, add a channel convert, and I'm going to convert from direction X, expand this and drop my direction under the source. And I can uncheck this, but it's not necessary. And here in the remapping, I'm going to leave everything as it, and I need to duplicate this 2 more times, and I need some appropriate naming like X, Y, and Z. Also in the field section, in the channel convert, it has to be direction Y, and with Z weight map has to be direction Z. Now I will go to X weight map, and here I will select this group direction, and here in remapping I need to enable remapping, uncheck these checkboxes, and into the direction section I'll change this to normalize. And now it's time to adjust my shader. I need a vertex attribute. Actually it has to be 4 of them, and here I will drop a weight map. Here would be my X, here would be my Y, and here would be my Z. And this vertex attribute outputs color, which has 3 components. I need only single one. Let it be scalar, scalar, and scalar, scalar. I will disable it. And if you remember, that's our X, Y, Z. So I'm going to make a vector out of that. Y, Z. Now let me check something. This linear field has to be disabled clumping, and here in direction I will change length to normalize, invert direction should be disabled. Let me check direction, and I need to disable invert direction. Now maybe we will see something. If you'll open render view, okay, we see a red color. Let me select linear field. If I will rotate this, something has changed. So I think we passed this vector into the 2D space, but now we need to affect the UV map. Let me hide it, open material again, and I need a dot product node. And here into the input I will put tangent. Here I will drop my 3D vector. Now I'll create additional dot product, and I will move the tangent here and this vector into here. Actually, this is just two float values. I need to combine them into a vector. But just with two components, X and Y, because the UV map is a 2D object. Now it would be better if I'll align it somehow. Now I'm going to use this texture as our sample, so I need to connect this offset with our vector right here. We'll connect this texture onto surface. Now let me open render view. Something is happening here, and that's not what I like to see. I think that's because inside our driver I need to enable remapping, uncheck clamping, and in the direction change length to no remap, uncheck this in the direction, and now I have unclamped direction across all the surface. Let me show render view again. Now let me select linear field, reset it, and currently my UV map is transformed in that direction only. But we not clearly see if it works properly or not. Now I'm going to attach this weight map onto the strength of that effect. Open it again, and we have this attribute with weight. I just need to multiply this like a vector map. This vector maker has to be input 1, and this has to be input 2. Put it here, move it here. This is here, this is here. Now let's see. Something has changed again. Let me select linear field and move it away. Maybe in that direction. Okay. Let me disable it. Let me disable wireframe. Let me move it a bit above. Now select this linear field. You see, now it's not affect this UV map anyhow. And if we'll start to move it, we see from the right corner our UV map start to come onto the left corner as long as we're moving it. I think it's time to switch to a different material. Let me go into the shader and change this to the tiles. Maybe I need to select this randomize, uncheck bevel, reset this, see it again. Something starting to appear to us. Now let me smooth it a bit. I will add a curve, select both the nodes and change point type to is. Now it's smoothly starting to distort my UV map. It just comes from yellow to red. Now let me show you something. In that texture, you can uncheck these checkboxes, so my UV map wouldn't be continuing after it comes out of the border. So under this UV map we can place different material. So if you add a color, and then I'm going to duplicate these two nodes. But with a different shader. I don't know. Let it be hexagons. And this is gonna be our base color. It's gonna be our second layer. Here on texture, I'm going to enable these checkboxes. Show you. Now we see two layers. The base layer consists of hexagons, and the top layer consists of red squares. And by moving our linear field, we uncover the second layer. Now you see some issues happen here. Let me reset it. And you see, when this linear field comes from a straight line and it's fully covered with other yellow, we don't see the top layer. That's because our setup moves UV map by the length of 1, which means by the length of this square segment. If I will move my UV map by the length of 1 in the direction or the direction, I can fully uncover the base layer. But if we will move from that point to that point, we have to build half of a circle here. And our setup will move our UV map only till this point. So I will reset this, move it by 45 degrees. So that's why we see this corner here. We can adjust that setup. I need a vector multiply, drop it here. Also I need a constant. Let it be, for example, value of 2. Drop it here. And swap these connections. Now you see, when it comes to full yellow, our base layer becomes fully visible. When I move it back, it's still okay. But actually, value of 2 is not proper value, because base layer becomes uncovered at this point, where we clearly see it's not fully come till that end, so we just offset it too much. Open the shader graph, and here on a constant you might adjust this value as much as you need it. Now let's see how it works with a different object, and maybe I will hide this and hide cube. For this cube I need more segments, let it be 50-50. Maybe delete also this perspective. Make this editable. Drop this text here. Open up render view and work with linear field. Okay. We are revealing the base layer using the same linear field. I can change direction of that linear field. Looking good. Just let me change the colors a bit. It's our base layer, and here I'm going to change red to green, and the blue to light blue. And the green has to be light green, and this grayish color, let it be yellow. Play with this again. colors. Okay, how it works with the torus. So I will disable this, enable torus. Actually, I need more segments, let it be sort of value. Make this editable. Open text. Open render view. Not look good, but still a nice effect. Now let's change linear field to a different one. Let it be, for example, spherical field. So unselect everything, create a spherical field, drop it here, and swap this here. Select spherical field, go to the mapping, change the offset, change direction to normalize, and leave this invert direction. Now I'm going to disable torus. I'm going to start with plane. Disable linear field. Now let's check. If you will move the spherical field, you see that effect. Still works. And now let's expand our UV map from the middle to the corners. Open material. Maybe for now I'm going to select these checkboxes. Let me play again with this material. When this checkbox is inverted, we see what our UV map going from the middle to the border of the spherical field. And when I check this, actually UV map is coming from the borders to the middle. So be aware of it. Let me select it and create new random field. Put it here, change it here, select it, and new direction. Change this value to normalize, and maybe uncheck invert direction. Go back to field. Here we need a scale of 1000, and let it be animation speed of 100. Let's play. Works good. Let me swap all this text with the torus. That's a nice effect. Now let me hide this. And actually I'm going to show you how it works with different objects. Let it be big man from the library. And comparable to the primitives, this model has a specific UV map. Let me open the texture view. You see there are some blank spaces between UV islands, and you have to know what if we will apply this effect to this UV map, it would happen that these empty spaces would substitute these spaces with UV map, so you will see a long part of the texture on the face, on the hands and so on. And while it sounds not too bad, let's see how it works in a real scenario. I need to copy this texture. Now I'm going to remove this tag from here, put it here, swap the nodes, hide the torus, and here in material I'm going to delete this connection, enter it here. Let's see how it works. Actually, it doesn't look great, but let me switch this from random to linear, enable it. Great, not that kind of good effect actually. If we will apply the same shader what we used on the primitives onto this texture, which actually would have no gray islands of the texture, it would be maybe a bit better. But as for me, it's not a good effect. Now I will quickly show a different setup. I will use this plane as a collider body. I will add a sphere, let it be radius of 20. I will move it upward for the same 20 centimeters. and I will make this view as a rigid body. Here on the collision shape I will change to ellipsoid, and back in the dynamics tab I will change the custom initial velocity to 100 cm on the x direction. I will move it a bit here. Now I'm going to increase max time to 150, rewind it, let's see if it works. Good enough. Now I'm going to break with dynamics, and I'm going now to trace the path of the sphere, just to disable trace vertices. Let me rewind it, reset. And actually this path will trace the center of the sphere, so I will add a plane effector under the trace, and I'm going to push it down a bit. Also I need to go to a point deformation mode, and it's better to change transform space to effector. Let's see if it works. Okay, my path is drawing, and now I'm going to use this spline as a deformation for UV map. So I will drop this tracer here, and in the tracer I'm going to change distance to radius. In the direction it's better to change length to normalize. Let's check UV map. It's not that big, so let's expand this, select tracer, change radius to 100 cm. Now let's see how it looks like. Let's play back from the beginning. Actually, it's already a good effect. You see, at that point we have some troubles. At that point we have a spline and it tries to push everything that is above that direction, what is below that direction, and we have some point of bifurcation here. So maybe if you'll go here on that right top, inside of a curve, if you'll move this here, and we'll add one more node here. Actually, what it does, when it's yellowish, it has a full transform, and when it's reddish, it has no transform. So here in the middle we have no deformation, and we even see that weird border. Let me open up a shader, and maybe it was better to enter value of 1, because it's too deformated. Also, with the same spline we can use different transformation direction. Just drop this tracer here, disable that, and here on the tracer, change length to normalize, and here on the layer, be sure that your distance mode set to along. So let's rewind it, hit A to redraw everything, hit play. Okay, you see, now my UV map is pushing in that direction where my ball is starting to move. So we use our spline mask to define the area of effect, and we use the direction along our curve to define the direction of the transformation. And now we probably wouldn't have any issues with deformation, so we can just disable that curve, or maybe enable it but change that like so. Let's rewind it, hit play. Actually not a that bad effect. Let's compare this by go to this direction and check this and check this, and hit A to redraw everything. Oh. Okay, I hope you see the difference. But actually everything I want to cover in that tutorial. You can check the sample scene in the attachment, and thanks for watching, bye bye.